All right, so question 5, all right. So question 5 just said, let f be the function defined above, right? So we've got that piecewise function. Is f continuous? So obviously we just have to know the definition of continuity. So remember, definition of continuity at x equals 1, very simple. Limit as x approaches 1 of f of x equals f of 1. So we have to, first of all, verify that the limit as x approaches 1 from the left is the same as the limit as x approaches 1 from the right. So I evaluate limit as x approaches 1 from the left by plugging 1 in to the top piece of the piecewise function. Then the limit as x approaches 1 from the right by plugging 1 into the bottom piece, and we get 7 for both of those, right? So then, of course, we know that the limit as x approaches 1 is 7. And then we have to evaluate f of 1, which, very simple, is just by plugging 1 into the top piece, which is, of course, 7. And so those two things are the same. So f is continuous at x equals 1 because the limit as x approaches 1 of f of x equals f of 1. So relatively simple, just based on the definition of continuity. Any questions on part A? All right. Part B, then, okay, this is a much bigger question. Find the absolute minimum value and the absolute maximum value of f on the closed interval -2 to 2. All right, so absolute min, absolute max. So we remember that if a function is continuous on a closed interval, and we just verified that it was continuous at x equals 1, but of course, this function would be continuous everywhere to the left of 1 and everywhere to the right of 1. So then it would be continuous on the interval -2 to 2. All right, and so we know that if a function is continuous, then the critical number test can determine the absolute max and or absolute min. All right, and so we find the critical numbers. Now we remember critical numbers means that f prime is either 0 or undefined. So first of all, I figure out when f prime is 0. And so I'm gonna figure out that on the left of 1, f prime would just be -2 minus 2x. I just took the derivative of 10 minus 2x minus x squared. All right, and so then I set that equal to 0, and I solve, I get x equals -1. And of course, x equals -1 is less than 1, so that works. All right, then I figure out when what f prime is on the right of 1, so x greater than 1. So now f prime of x is 4e to the x minus 1, right? And remember, that's the derivative of the bottom piece of the piecewise function, which is 3 plus 4 e to the x minus 1. Now, we should know that this thing is not equal to 0, right? Because a basic graph of an exponential looks like this, has a horizontal asymptote of y equals 0. So it is never equal to 0, meaning the derivative is never 0 greater when x is greater than 1. All right, but then we also have to understand when f prime is undefined, right? So it's undefined at endpoints, that would be -2 and 2, and it's also undefined at x equals 1 because the derivative on the left and the derivative on the right are not equal, right? The derivative on the left of 1 is -4 and the derivative on the right is +4. Therefore, f would not be differentiable at x equals 1. And so we have 4 critical numbers, right? Critical numbers would be -2, -1, 1, and 2. Okay, a lot of times people forget about endpoints, which is problematic. All right, and so then I just do the critical number test by evaluating the function at each of those critical numbers. So f of -2, f of -1, f of 1, which we already figured out, and then f of 2. All right, and so I get those values, 10, 11, 7, and 3 plus 4e. And so then I need to know which one of those is the least, obviously 7, and then which one of those is the greatest. You know, I don't know if for some people 3 plus 4e isn't immediately obvious that it's greater than 11, but very simply, if e is between 2 and 3, then this thing would be greater than 11. Okay, so any questions on part B? No questions? Okay. All right, then let's move on to part C. All right, part C says, find the value of the definite integral 0 to 2 of f of x dx. All right, and so we are evaluating the integral from 0 to 2 of f of x dx. Now, we have to remember that the integral, or the function, is defined less than 1 and then greater than 1. And so we need to evaluate the integral from 0 to 1 of the piece that's less than 1, and then add to it the integral from 1 to 2 of the piece that is greater than 1. All right, and so both of these we evaluate by hand. So integral of 10 minus 2x minus x squared, and then the integral of 3 plus 4e to the x minus 1, and then we're plugging in 0 and 1. Now, I did say this line right here is sufficient in a free response question. You do not need to go any further from this. However, if you do simplify, then you end up with 23/3 minus 4e. Any questions on part C? Okay. All right. So that's problem 5. Okay. Any other follow-up questions on problem 5? All right. Pretty quiet group today. All right. Let's move on to problem 6 then. All right. So problem 6. Let me just open up the question. All right. Problem 6 says Kathleen skates on a straight track. She starts from rest at starting time t equals 0 for t between 0 and 12 seconds. Velocity k is measured in feet per second, is differentiable and increasing. Values of k of t at various times t are given in the table above. All right, part A, use the data in the table to estimate Kathleen's acceleration at time t equals 4 seconds. Show the computations that lead to your answer, and then indicate units of measure. All right, so remember, acceleration would be the derivative of k of t, because remember, k is the velocity, right? And so we're estimating k prime of, well, I wrote t prime of 4, right? So we're k prime of, and so the best way that we can do that is by finding the slope between 3 and 5, right? Because obviously 4 falls right in between. And so that would kind of be like, the way that I think about it is I only have these points, right? I have like a point here, a point here, a point here, a point here, and a point here, right? And so let's say I want to estimate the slope right here. And so the only way that I can do that is by taking the slope between the two neighboring points. All right, and so I evaluate the slope between 3 and 5, so k of 5 minus k of 3 over 5 minus 3. 5 over 2, which of course is 5 halves. If you left it as 10 minus 5 over 2, that would be acceptable, but it's not acceptable to leave it as k of 5 minus k of 3 over 5 minus 3. All right, and then of course you need to give the units. And so remember, I took the units of k, which were feet per second, and the units of t, which were seconds. So I have feet per second divided by seconds, or feet per second squared. All right, that is part A. So now, if you look at the scoring, part A, you get a point for having the estimate, like the numeric value, and then you get a point in the units. All right. Moving on then to part B. All right. Part B says use a right Riemann sum with 4 subintervals indicated by the data in the table to approximate the definite integral from 0 to 12 of k of t dt. All right, so let's start there. All right, so I am using the right Riemann sum, okay, to estimate this integral. So remember, the right Riemann sum is going to be taking the width 0 to 3, so 3 times the right-hand value, plus the width from 3 to 5, which is 2 times the right value, plus the width from 5 to 8, which is 3 times the right-hand value of 20, and then plus the width from 8 to 12, which is 4, times the right-hand value of 24. And so I got 3 times 5 plus 2 times 10 plus 3 times 20 plus 4 times 24, which of course does simplify to be 191, which, like I've said before, you do not need to simplify that numeric value. All right, now the units, remember, we are taking the time, which is seconds, and multiplying by k of t, which is feet per second. So of course, seconds reduce, and we're left with just an amount of feet. Okay, then the next part of the question says, is this approximation an overestimate or an underestimate for the value of the definite integral from 0 to 12 of k of t dt? So you are told that k of t is an increasing function. So if it's increasing and you think about a right Riemann sum, that would mean that this is an overestimate. Now, if you had a function that was decreasing, a right Riemann sum would be an underestimate. Okay? Now, sometimes they ask like an overestimate, underestimate question, you know, for some other things, right? Sometimes we use like a tangent line. I think we had a free response earlier that we had, like you were told, here's this curve, right? Looks like this, and you're using a tangent line to approximate a value of the function, right? We had a question like that one, I believe. So the fact is that this tangent line would give you an over approximation if the curve is concave down, but if the curve was concave up, the tangent line would give you an under estimate or an under approximation. Okay. Now we also have a question like the Riemann sum one here, but let's say you have like an increasing and concave down curve, and you used a trapezoid to estimate, right? A trapezoid would be an underestimate because this curve is concave down. But had this curve been concave up, a trapezoid would have actually been an overestimate. So do you see how those two would work? It wouldn't matter if the curve, if the function was increasing or decreasing. It would matter in this instance whether the curve is concave up or concave down. And that has been a question that has shown up in one of these kind of given a table of values, Riemann sum, you know, estimate questions. But it would be, in that case, it would be a trapezoidal sum question. Okay. Any questions on that?
So if we said that it was concave up, would that be wrong for this question?
I don't believe you know that it's concave up.
Okay.
It says Kathleen's velocity, k, is measured in feet per second, is differentiable and increasing. So all you know, right, k is increasing. So that means its derivative is positive. Is that
Okay.
right? You don't know that k is concave up or concave down. Right?
Okay.
But so like actually this picture that I drew, I did actually draw part of it that was kind of concave down, and then I guess it looks bad here, but it looks like it's concave up there. So it doesn't actually matter for a right Riemann sum. It doesn't matter if it's concave or concave down. It's still going to be an overestimate.
Okay.
Question about the next one.
Of course.
C.
Part C. Yep.
In the answer, it just said 5 plus the absolute integral from 0 to 12 of n of t.
Yep.
Could you still get the points if you actually wrote what it said was n of t? Like,
Oh, yeah, of course. Yeah, if you gave that function like 150 over t plus 3 minus 50 e to the negative t instead of n of t, that would be totally fine.
Okay. And just to make sure, like, you have to put the 5 outside, otherwise
Correct.
it's different. Okay.
Yep.
That's what I thought.
Yep. Do you want me to talk about C in more detail, anyone? I mean, there wasn't really a lot to that. I mean, really not a lot of work, but it's still worth 2 points. One for actually knowing to integrate n of t from 0 to 12, and then one for having the 5 added on the outside.
Wait, sorry. Why did we add the 5?
So you were told that Nathan starts 5 feet ahead of Kate or of Kathleen. And the fact is that Kathleen was at the starting, what is it? What is the actual text it says? Is at the starting line.
Mm-hmm.
So, you know, so if you're counting where she starts as 0, then he's starting at 5, right?
But when you find the integral, doesn't that like just get the
So
area of the curve?
the integral represents the amount that Nathan has traveled, right?
Oh, okay.
So you're taking the amount he has traveled plus 5 because he started. Remember, the question says, write but do not evaluate an expression involving an integral that gives Nathan's distance from the starting line. So you have to read into the fact that he started 5 feet ahead of Kathleen, and Kathleen started at the starting line.
Okay.
So basically, like if you said, okay, where is Nathan at t equals 0? You would say 5 plus the integral from 0 to 0, right? Obviously, like 0 to 0 would be 0, but where is Nathan at 2 seconds? It would be 5 plus the integral from 0 to 2.
Yeah, that makes sense.
All right, so that's part C. All right, part D. Write an expression for Nathan's acceleration in terms of t. All right, so very simple here. We're just taking the derivative using the product rule, right? And so we're taking the 150. Oh, actually, I rewrote n of t just to 150 over t plus 3. I just rewrote it as 150 times t plus 3 to the negative first. And so then I have, I bring the negative 1 down in front, negative 150 times t plus 3 to the negative second, and then, of course, times the derivative of t plus 3, which is, of course, just 1. And then I have minus 50 times the derivative of e to the negative t, and the derivative of e to the negative t would be e to the negative t times negative 1. Now, of course, you can just leave it just like that. No, you don't have to go any further. This is just fine for n prime, all right? But then this is the, kind of, I don't know, the nicer looking answer, whatever. That's the answer that the rubric gave ultimately, but it's really it's no different. Now, let's say that instead of just say find the acceleration, what if it said like, find Nathan's acceleration at t equals 5 or whatever, then of course you'd be plugging 5 in here, but you wouldn't have to actually like, simplify that or whatever. It would just be a, a numeric value that's just fine. All right, any follow-up questions with that?
This is for C. Oh,
You go first.
wait. Okay.
Yeah, of course.
So I would still get a point if I wrote an integral, right? But forgot the plus 5.
Oh yeah, yep. If you
Okay.
had the integral from 0 to 12 of n of t, you'd still get one of those 2 points.
Okay, cool. Thanks.
My question is there anything we should be doing other than just like doing the FRQs to be preparing for the AP test? I know you sent the video from the College Board.
Yeah, so basically, it started yesterday, and I posted something about it yesterday, but every day there's going to be a different topic that's being reviewed on the College Board website, or not on the College Board website, on the College Board's YouTube channel. So I think that would be a great way to, just give yourself a chance to review a lot of those ideas. And then in 2 weeks, I believe, I'd have to look back at the playlist on the YouTube channel, but in 2 weeks, I think they're going to start having some more targeted questions, like getting you ready for what's actually going to be on the AP test. I could be wrong, but I'd have to double check that, and then we would probably push those links out as well. And while those ones are live, like right now, they're doing a live one on the derivatives review, but after the live feed has ended, then they post those videos and you can watch them at any point.
Okay, but there's nothing else that we like should be doing.
No, I mean, I think that a lot of people think that they, should be doing so much more. And obviously, if we were preparing for a multiple choice test as well, we would be doing, more multiple choice and things like that. But for right now, if you guys, and obviously you 6 that are on this call, are doing what you're supposed to do. But basically, if you're practicing the FRQs and then you're figuring out what you did or didn't do correctly, and you're looking at, the rubrics and things like that, you know, I think you're probably going to be prepared. But like I said, we're gonna, you know, keep looking at the stuff that College Board is putting out and telling us is gonna, you know, be on the test, and then we're going to continue to refine the content that we're giving you to review. All right. Anyone else have any other questions? All right. Short meeting today. We'll have 2 more FRQs tomorrow, and then we'll do the same thing. So I guess we'll see you guys on Thursday.
Bye, everybody.
All right. See you guys.